Hey guys, today I'm going to be showing you how I carved out both of these slingshots using my X-Carve Cnc. So as you can see, this first slingshot is in my TAOW hammer design, and the second slingshot is in Yorksbrov's Rambone slingshot design. You can also see the massive comparison in size. The TAOW hammer design was made for my sized hands because I designed it myself and I've got quite small hands, and then the Rambone slingshot design was made for much larger hands, and as you can see, it's much too big for my hand. So if I wanted to make it again, I would probably try and scale it down somehow in the CAD program. Both slingshots are carved out of 3 layers of 18mm furniture grade multiplex plywood. This means that they've got a pretty nice contouring pattern and they're both incredibly strong. So now let's see how you make them. So first off, I imported the SVG outline rendering of my TAOW hammer slingshot into Easel, which is Inventables' own CAD program which is online and works really well with the X-Carve Cnc. I copied it 3 times and then turned it over and upside down and tried to link them together so that they would take up less space. I could have actually, now looking back at it, moved them even closer together. Then I would have saved even more of the plywood. I need to make sure that I set Easel so that it cuts an outline cut of my slingshot, otherwise it's not going to follow the correct line. You can then generate the toolpaths and have a look at them and see if they look okay, and I think that they look pretty good at the moment. Make sure that on each piece you have used tabs selected, and this is going to mean that each piece is going to be cut out and it's going to have a little tab left over, which is going to mean that it's not going to come loose as the final layer is cut out. Once you're happy with everything, you can go up and click carve and then set up your machine for carving. Once that's done, you can then cut out the slingshot. Your machine is then going to start cutting everything out, and obviously, as you can see, this is only cutting out the outline of the slingshot 3 times. That is, for this slingshot, since it's my very first slingshot that I'm going to be carving out, I'm going to be using very basic cutting techniques. I'm just going to be cutting out the outline and then finishing off the rest with hand tools, doing all the shaping. For the Rambone slingshot, which actually has a 3D STL available, I'm going to be following Winston Moy's tutorial and then doing all of the different 3D carving, doing all of the cutting out with the CNC, but I'll be showing that on later in the video. As you can see at the moment, Easel is using some very inefficient toolpaths, and that's because there's a lot of travel time as it cuts out one layer of a slingshot and then moves on to the next outline. This has been updated in a newer version of Easel, but I cut this out before that was released, and in the newer version of Easel it cuts out one slingshot at once and then moves on to the next one. Once all 3 layers have been cut out, I can then undo the screws which I was using to hold it down. I can then quite easily just use a craft knife to remove all of the thin tabs which were left behind to hold the layers in place. So this is the 3 designs afterwards. Apart from the tabs, they're pretty much all exactly the same and they'll laminate together really well. For the last cut to cut out all 3 slingshots, it took about 3 hours, so that's an hour per slingshot, but that was due to Easel's really inefficient toolpaths, and I was also using some conservative feeds and speeds. Now I'm going to up the feed rate to 600mm per minute and 0.6mm depth per pass using a 1/8 1 flute upcut end mill, and I'm going to just cut out 1 slingshot and see how long it takes. It only took 30 minutes to cut out this outline, and I know that's a lot longer than it would take just doing it by hand with tools, but this is much more precise and it's exactly symmetrical. As well, I can just walk off while it's doing it and I can do something else. To laminate all of the layers of the slingshot together, I'm going to be using wood glue, but the problem with this is one of the layers, since this wood was used for furniture, has got varnish on, so that's got to be sanded off with a belt sander first, so it's a wood to wood contact. You can see the difference in the surfaces once I've finished sanding off, and the one on the right is the one that's been sanded and the one on the left is the one that's still got varnish on. The layers are then laminated together using wood glue. As you can see at the moment, the slingshot is really thick and unergonomic, so what I need to do is I'm going to use hand tools to shape the rest of the slingshot so that it looks something more like one of these finished slingshots. The rest of the shaping was then of course done with hand tools using wood rasps, sandpaper, Dremels and things like that, and I'm going to be glossing over this sort of DIY process since I've done it hundreds of times in other videos, and this video is mainly focusing on the CNC aspect of slingshot making. So for now I'm going to put that slingshot aside and focus on 3D milling this and CNCing the Rambone slingshot out, hopefully doing much less shaping with hand tools and doing much more shaping with the CNC. So for cutting out the Rambone slingshot, I followed a tutorial by Winston Moy. This is a really great channel that I would really recommend if you're getting into CNCing, and he's got a lot of good tutorials on how to cut out slingshots and do other CNC projects, and he basically shows you the exact way to import the STL of the 3D Rambone slingshot into a program called Meshcam, which you can get a free 15-day trial for, and then he shows you how to cut it out and how to do all the toolpaths and everything, and I basically followed that. The link will be in the description to his channel and also to the 2 videos which he showed on the Rambone slingshot slingshot process, and I'd really recommend that you check him out even if you're not going to attempt this project but just have a CNC. So first step in this project is to go over to simpleshot.com and download the STL for the 3D Rambone slingshot. This is freely available and Yorkspro have released it with 3D printing in mind, but with a couple of tips and tricks we can use it for CNC milling. I then open it up in Meshcam, which is a free software for 15 days, and as you can see I've only had it for a day now, and you can just download it for free if you have an email address, and when you open it up you can see the full 3D model of the Rambone slingshot. Obviously, since my machine is only 3-axis, I'm not going to be able to mill any of these overhangs, so what I'm going to have to do is go into geometry and go into slice, use Meshcam's inbuilt slicer to slice this up into 3 different parts. I set the thickness to 18mm because that's the same thickness as the plywood which I'm going to be using. What this will then do is Meshcam will then save 3 different STLs of different slices on the geometry. Once they've been saved you can then open them up, and some of them might be upside down and you're going to have to be able to rotate them, so just click on any of the axes and then click rotate by 180 degrees. As you can see, this is then split up the 3D Rambone slingshot into 3 different pieces, all of which I can mill out separately on the CNC and then stick together afterwards. With all of these different tools along the left you can define your stock material and then move straight onto tabs. These are pretty simple to add, you just click whenever you want to add them and then right click if you want to remove any of the tabs, and I've just got my height 2mm and then 3mm wide, and that's going to provide enough support to hold the piece in place while on the finishing pass. Once you've got your tabs in the right place, you can then move on to all of the different machining and generating the tool paths. You can input all of the different tools and select all of the finishing passes that you want. If you want to see more detail on this, visit the original tutorial done by Winston Moy. Once you click done, it then takes a little while to generate all of the different tool paths, but once that's done you can easily visualize where the tool's going to go and how long it's going to take if you click estimate machine time. Save the tool path and then repeat this for the other 2 slices, and you've got all of the different tool paths which you're going to need. Now you just need some time to cut them out. I sent the G-code for the parts using Universal G-code Sender since it has a built-in G-code truncator, since when you use Meshcam it outputs massive decimals if you use it in millimeters mode, which I was using it in since I'm in the UK and I don't really know inches too well, and it outputs massive decimals which Gerbil can't process, and it will send your machine to impossible locations or just completely break the cut. So you need an inbuilt G-code truncator, or you need to post-process the G-code, otherwise it won't work. Or you could just do it all in inches, but I prefer millimeters. The way that Meshcam mills out a 3D image is it uses a roughing pass and then a finishing pass. The roughing pass is very rough with a very low step over, it takes a lot less time and it takes out big chunks of material but leaves a very rough finish. It then goes over the geometry with a finishing pass, which then cleans up the material and makes it much smoother. You can select the finishing pass to either go on the Y or the X or both. I decided to just do it on the Y so that then it will cover the most of the material but not take too much time. This first piece took 2 attempts since the GT2 belting on the X-axis came loose yet again, but that was before I'd fixed it. But now I've fixed it, it only had a slight imperfection and I'm just going to leave that in since it reminds me of the machining process. Also, as you can see here, it's gone all the way through the 18mm plywood and it's only left the tabs behind. I then repeat the process with the other 2 slices of the geometry of the Rambone slingshot. Each part took about 1.5 hours to 2 hours to cut out, and depending on the different finishing passes and the tolerances and the step overs that I used, and I used a different one for each one, so there's no exact time, but it did take quite a long time. So this is what it looks like when it's done. I think it looks pretty good. It's a little bit rough, and in most places it's gone all the way through, which is good. So this is what all 3 of the parts look like after I've finished cutting them out with the CNC, and as you can see they fit together quite nicely and they line up almost perfectly. Once they've been glued together there will barely be any sanding and then it will make one solid slingshot. Since the plywood that I was using had a bit of a varnish coating to make sure that it was waterproof and just stain proof, I need to sand that off before I can glue it together using wood glue. Then using wood glue that I picked up from a local hardware store, I can glue all of the different pieces together. I just apply a thin layer of wood glue to 2 of them and then hold them together using elastic bands. Once the first side is set, I can then remove all of the elastic bands and attach on the other side. The other side is glued on the exact same way, and it only takes the glue about 2 hours to set just so that I can remove the elastic bands. And the reason that I use elastic bands is because clamping it up with clamps and a vise on this uneven geometry like this would be quite difficult, so elastic bands are much more easy. So the glue's set and all of the layers are held very solidly together. Now all it's going to require is a little bit of light sanding to remove all of these pieces which were tabs holding it on together, and then it will be a finished slingshot. I've decided that I'm going to leave in these machining marks because I really like them and it gives the slingshot a really cool texture. So this is what the two slingshots look like after I've finished sanding them. As you can see on this one, I've left in the machining marks and I think they look pretty cool, and both of the slingshots feel really nice. You can also see the comparison in the size. My tail hammer design is much smaller and fits my hand much better since I've got smaller hands, but if I had larger hands I think the Rambo slingshot would be perfect. So to bring out the grain and the contrasting colours between the layers and the plywood, I'm going to be using some boiled linseed oil to oil the wood. So here you can see the contrast between the unoiled slingshot and the oiled slingshot. Now it's time to oil this one. After they've both been oiled, I drilled 2 holes in the top where they were meant to be, just continued all the way through to this side because the CNC hadn't got all the way through, and drilled this hole in the side because obviously when it's like this the CNC can't drill sideways holes. So that's the lanyard hole done and the 2 band attachment holes done. Now it's time to band up the slingshots and see how well they compare and shoot to each other. Both slingshots are now banded up with some TheraBand gold, double layered, tapered with a leather pouch at the end, and they're made to fire 15mm steel ball bearings. I've got quite a large target set up over there because I've never used a Rambo slingshot before. I'm used to this design and also haven't been slingshot shooting for a while, so let's see if I can hit it. Both slingshots shot pretty well and I'm happy with them. So now where could I take this in the future? Well, since I 3D milled the Rambo pretty much and I barely had to do any handwork on it and I could just leave the CNC going and it creates pretty much perfectly symmetrical slingshot, what I'd really like to do is to be able to do that on a tail hammer design. And I've tried designing it in a CAD program, but it's almost impossible to get all of the different curves, well at least for the basic knowledge that I have. So I have this tail hammer slingshot that I really like and I love the shape of it. It's probably the best one I've made of cast aluminium, and I would really like if I could somehow 3D scan this. My school's got a 3D scanner, but I'm not sure whether I'd be able to use it or not. If you know of any companies that I could send away to try and get this 3D scanned, that I know this would be safe and would get it back because this is quite valuable to me, then I'd really like if you posted them in the comments section down below. Or if you know of anyone who would be able to maybe design this in a CAD program with my help, then that would also be really useful. Thing is, if I then did have this in a 3D STL in a CAD program, I could then do the same thing that I did with this slingshot, but on this slingshot, and be able to mass produce them and possibly even start selling them if I got enough multiplex plywood. Obviously it would require me making some of the G-code more efficient and things like that, but I think it would be doable with someone's help. Oh well, that's all for today. Make sure that you check out Winston Moy's channel and his 2 tutorials on how to make the Rambo slingshot, since I wouldn't have been able to do this without his tutorials. And if you have any other ideas on what you think I could make with this great CNC sent to me by Inventables, then I'd really love it if you posted them in the comments section down below. I've got a couple more ideas that I'm going to make, but I need some more ideas fueled by you.